Everybody seems to have one tomorrow. What's this, like your last test before finals?
Yep.
Okay. What do you want to go over?
I'm just gonna go over all the practice test problems, make sure I know how to do it all.
Okay.
Alright, first problem is root x minus 3. It's all inside the root. And then equals root x plus 1.
Okay. Go ahead.
Okay, so square both sides.
Yeah.
You get x minus 3 equals x plus 1. And then from there you could just do plus 3 and then minus x. So this would be no solution, right?
Correct. Whenever you get one number equals another number, that means impossible. No solution that would ever be true.
Okay.
Okay.
Okay, so it says simplify the difference. 5 root 3 minus root 27.
Okay, now you can only simplify that as if you can end up with both of them having the same root. In other words, I cannot operate with root 3 minus a root 27. But if I can change the root 27 into something, I might have a bunch of root 3s. So what's root 27 do?
That would be 9 and 3.
Okay.
So that would be 3 root 3.
Okay. And what's that equal to?
That would be 2 root 3.
Okay. Good?
Yep. Alright. Next one is solve. So root x, and then outside minus 6 equals 8.
Okay. Next line.
It would be root x equals 15. Or what? No, 15. Sorry. 13.
14.
14. God, I'm not doing good today.
When you're
Anyways,
always remember, when you're adding even numbers, you better come up with an even number. Adding or subtracting. You cannot come up with an odd number. It's impossible. All even numbers produce even numbers. Now what?
Square both sides, so that would be x equals 196.
Okay.
Alright, next one. Alright, x equals root 5x plus 14, and it's all in the root.
Okay. Next line.
X equals 5x plus 14.
Hold on.
X squared equals 5x plus 14. Then from there it'd be x squared minus 5x minus 14 equals 0.
Keep going.
Then that would be x minus 7 x plus 2.
Keep going.
And then x would be equal to 7 negative 2.
Now, because we have a radical, it's probably worth checking both of those solutions. If you don't have to necessarily check them all the way out, just make sure one of them does not result in a negative number in the radical sign. In other words, if I plug in minus 2, I still have a plus 4. Oh.
Okay.
But no, that one doesn't work.
That'd be negative 10.
Negative 2 equals the square root of 4, which is not true.
Just 2. Right. Okay, so it's not. So it'd just be 7, right?
Well, the square root of 4 is positive 2. So
Right.
7 works, I believe. 7 equals the square root of 35 plus 14, which is 49. So yeah, 7 works, but only 7.
So it'd just be 7.
Just be 7.
Okay.
Remember, both of these things don't have to be 0, just one of them.
Okay. All right, next one is a graphing one.
Okay.
It's y equals root x plus 3. It's all in the root.
Parent function?
X.
You've learned like 8 or 9 elementary functions. Okay, let me write them over here. You've learned this one. It's linear. You've learned this one. 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 Which one of those is our elementary function for this particular case?
Y equals root x.
Okay. What if it was square root of x squared plus 3? What would our elementary function be?
Say that again?
If I...
Oh, wait, what?
Yeah, in other words, the elementary function would still be y equals square root x. That's all I did is confuse you and me by saying that. Usually the elementary function is fairly apparent, but you have to know your elementary functions.
Okay.
Okay. So I start off by graphing that. Domain of x is all positive numbers. The range of y is all positive numbers and 0. So it kind of looks like that.
Okay.
Y can never be negative and x can never be negative.
Mm-hmm.
So now what transformation has taken place? What's the difference between this function and our elementary function?
That there's a plus 3.
Well, first of all, tell me if it's a vertical transformation or a horizontal one.
It's a horizontal.
Horizontal, sorry. Always inside the function, and it's inside the radical sign. It makes it inside the function, makes it horizontal. Is it a shift or a stretch?
A shift.
Correct, because it's being added or subtracted. It's not multiplying. If it was multiplying, it would be a stretch or a shrink.
Right.
So it's not a reflection. There's no negative signs anywhere. So it's a horizontal shift. The only thing left to ask is which direction.
Left, right?
Yeah.
So how do you determine that? Do you just flip the sign?
What?
Okay. All right, yeah, you answered my question.
Okay. Yeah, that's the best way to remember it probably, is it's the opposite of that sign. Okay.
All right. Here's the next one. All right. So 4 root 9m times 5 root 1/9 m to the third.
Like that?
Yeah.
The whole thing's in there?
Yeah.
Okay. Looks hard, but it's not. Okay. Best thing to do is to write each expression as a fractional exponent instead of with a radical sign.
Okay.
Okay? In other words, how do I write this? It's 9m to the 1/2, right?
Mm-hmm.
Okay. How do I write this? 5 times everything in the radical sign to the 1/2, right?
Okay.
Now, let's go over to this left part here. I can take the square root of 9 and take it out, right? So that becomes 3 times 4. In other words, the 4 is not being taken to the 1/2 power, just the 9. And
Okay.
the m. So that part becomes that. This part becomes 5. Is there anything I can do with that 1/9? Can I remove? What's the square root of 1/9?
Oh,
A third.
a third. Okay.
So yeah, I can take that 1/9 outside, leaving behind m cubed to the 1/2. Now I can apply my rules of exponents. What does that turn into? What does m cubed to the 1/2 turn into?
So wait, hold up. So how did you get 12m to the 1/2?
Okay, this 3 right here, or this 9 right there, the square root of that is 3.
3, right?
3 times 4 is 12.
Okay.
And what's left over is m to the 1/2.
Right.
Okay. I did the same process on the second part. Is the 1/9 is under the radical sign, or so if we can remove it, we make things a lot simpler.
Oh.
And you can take the square root of 1/9. It's 1/3. So I remove it. It's going to get multiplied by this 5 over 3. But more importantly, how can I write that? Using the laws of exponents.
You could do 1/2 m cubed, or
That comes out m to the 3/2. When I multiply this times this, I get m to the 3/2.
okay.
Okay, so now I'm going to multiply my 5 times the 12, divide it by 3, and I've got m to the 1/2 times m to the 3/2. You with me? What does all of that become?
How do you... Alright, wait, I got this. So, it would
Handle the number
probably
first.
20.
Okay.
M to the, just 20m, right?
What do you do to the exponents when you're multiplying? You add them. You always do one level less. One level less than multiplication is addition.
Okay.
Up here, we had exponentiation going on. One level less than exponentiation is multiplication.
Right.
If we were dividing the m's, we're going to subtract. So you always do with the exponents one level less mathematically than what is being done with the base. Well, I'm multiplying m times m, so I'm going to add the exponents, and that comes out to 2. 1/2 plus 3/2 is 2. And that's your answer. As simplified as it can be.
What? I don't understand how you got 2.
I added, okay, here I got 1/2 times m to the 3/2. I am multiplying the same basis, different exponents. I add the exponent. That's m to the 4/2.
Oh, okay, and then simplified is just 2.
Exactly.
Okay.
Okay.
Alright, next one.
Here, let me give you, hold on a second. Let me just test you here, since you had a little bit of a problem with that. What's that?
X to the 7th.
What's that?
It's X to the 11th.
No, you gotta subtract the exponents.
So X to the 10th?
Yeah, because there's a hidden 1 right there.
Right. Okay.
Okay. And finally,
that would be, that'd be X to the 12th, or?
multiply those two. What is 3 times 1/4?
What?
What is 3 times 1/4? It's 3/4, right?
Oh, yeah, okay.
If you have a fourth of a piece of pie and 2 of your friends give you their fourths, you're going to have 3/4.
Right.
Okay? But the way to think about it is put a 1 under there. Now you're multiplying fractions, and when you multiply fractions, you multiply numerators, you multiply denominators.
Okay.
Okay? So there's your 3 rules of exponents.
Cool. Okay.
Okay? That covers everything you're going to cover in here. But that's why I wanted to make sure you knew them precisely.
Alright, next one. It's a word problem, so. Okay. Alright. You are making a tire swing for a playground. Okay. The time t in seconds for the tire to make one swing is given by t equals 4 root L over 5.8. Where L is the length of the swing in feet. You want one swing to take 4.5 seconds. How many feet long should the swing be?
Did I write the equation down correct, or is that 5.8 outside the radical?
That is correct.
Okay. And they said
4.5 seconds.
So how do I solve this?
Alright, so wouldn't it be 4.5 equals 4 root L over 5.8? And then, from there, can you divide by 4?
Uh-huh.
Okay, definitely. So divide.
And that's the best way to do. You could also square both sides, but that just makes that 416. So it makes it get bigger. We don't want to do that. Let's go ahead and divide both sides by 4. You get what?
Okay. You get 1.125 equals root O over 5. Then from there, you would square both sides.
Okay, what's the left side squared?
That would be 1.265625.
265. We'll leave it rounded off to the nearest thousandth. What's the right side become?
Wouldn't that just be L root 5.8?
L what?
Over 5.8, sorry.
Okay. Yeah, not L root 5.8.
Yeah, I don't know why I said that.
We square both sides. We got rid of that radical sign on both of them because they were both inside the radical sign. Now what's L going to be equal
to? L? Wait, so would you subtract a 5.8 or?
No. What's 5.8 doing right now? You got to get rid of it.
Okay, so divide, right? Or
what is it doing right now?
Dividing.
So you always do the opposite.
Multiply. All right, so.
Always. Something's being taken, the square root of it, you square it. Something's being squared, you take the square root of it. Something's being added, you subtract. If something's being multiplied, you divide. It's always the opposite.
Okay.
What's 5.8 times that number?
let's see this. That'd be 7.337.
Now, were there any instructions as to rounding it off to the nearest place?
Do not round until the first answer, then round to the nearest tenth as needed.
Okay. So what that means is don't round that one off.
Alright, so that would be...
However, you can kind of be fairly certain that you're not going to have extra round off error because this is going to round off to 7.3, right?
Uh-huh.
For it to make a difference, this last 3.7 would have to be above 5. That second 3 would have to be above 5. And there's no way that difference, that extra 125 that was on the end of that, is going to make that big a difference. So it's okay to round off in the middle as long as you use enough places in the end that, in other words, you wouldn't want to just get 7.33. I don't know if that, I'd feel safe there. But, let's just follow her directions. Don't round off until the end. In other words,
Okay.
go back and square 1.125.
Okay.
Don't read me the answer. Just take that answer and multiply it by 5.8. Now what do you get? In other words, take the unrounded one. Multiply it by 5.8.
Alright, let me do this.
That's what she's requesting you do. Is do not round off at
multiply that answer.
What's that?
By 5.8. So multiply that answer by 5.8.
Yeah. And that way you can multiply the full answer. You don't have to do any rounding.
So 7.340625.
Ah, it did make a difference. 7.34. No, it didn't make a difference. Okay? Because now when we round, this is where she wants you to round.
So 7.34.
No, to the nearest tenth.
Oh, so 7.3.
Nearest tenth means 1 decimal place. Nearest hundredth would mean 2 decimal places. Okay, so it really didn't matter. We were going to get 7.3 regardless of where we rounded. But it does show you that it can make a difference. It actually made a significant difference in the answer. If we were rounding to 2 decimal spots, it would have mattered. In one case, we would have gotten 7.34 this way, but if you round too soon, you were going to get 7.33. No, that second 3 would have rounded up to a 4, even then. But it can make a difference. It just didn't in this case.
All right. Next one's graphing.
Okay.
It's y equals 7 root x.
Like that? It's a parent function.
Root x.
Is this a vertical or a horizontal transformation? What is it?
Vertical.
Okay. Is it a reflection?
Yes.
No, there's no negative signs.
No. No negative.
Okay. Either reflection, either over the y-axis or over the x-axis, you got to see some negative signs there. So there's no reflection. So now the only thing we have to determine, is it a vertical stretch or is it a shift? It's a shift. No, remember, shifts come from adding and subtracting numbers. They don't come from multiplying numbers.
So it's a stretch.
Think about it like that. How tall are you?
5'8".
If you want to increase that, you got to do what? Stretch.
Stretch, right.
You got to multiply. You got to multiply your height by 1.1, and you'd stretch, and become a little bit taller, right? If you stood up on your tippy toes and put your hands up above your head and stretched out, you'd stretch out quite a bit. So that's the way to remember it, is remember that stretches are multipliers. And stretches also change the shape of the curve. Shifts do not. If this was a square root of x plus 7 with the 7 outside the radical, then that would be a vertical shift, and as all that would do, it'd just be move everything up by 7, and it would look exactly the same as the first curve. But this is not. This is a stretch, and that does change the shape of the curve. In other words, that point is still on the curve. When x equals 0, y is still equal to 0. But every other point is 7 times further away from the x-axis.
Okay.
So this stretched curve looks a little like that. In other words, it's vertically stretched. And really the way to think about it is if I have a point right there that's equal to 1, well, on this curve, that point's got to be equal to 7, right?
Right.
7 times further away from the x-axis. When I get up to here, and that is equal to 2, well, up here, that's got to be 14, because it's 7 times.
Right.
So the effect is a significantly changed shape, which all stretches. Now, stretch goes also with the word shrink. In other words, if I make this a 1/2 instead of a 7, then it shrinks it like that. Every point is 1/2 of the value that's on the red curve. And you can see it's a different shape also. So stretches and shrinks result from multiplication.
Right.
Shifts result from adding or subtracting. Doesn't matter whether they're horizontal or vertical, they do not change the shape of the curve. Shifts do not. Okay.
All right, next one's the graph one too, but it's a parabola this time. All right, y equals x squared minus 4x plus 7.
Like that?
Yep.
Really? Y equals x squared minus 4x plus 7?
Yeah.
And they just want you to graph it?
Yeah.
Okay. Well, there are several techniques that you can use to graph a quadratic. The first one I would think about would be to see if I can factor that. Because if I can factor it, I immediately put it into x minus p times x minus q, where p and q are the y or the x-intercepts. And that shows you where a lot of stuff is. Once you know where the x-intercepts is, go halfway between it and you got the vertex. Okay? So that's one way. But this doesn't factor. That's why I said really. Okay? But that's okay. We can, there's still, when it doesn't factor, there's still 2 or 3 ways to figure out how to graph it. My favorite is to get the x coordinate of the vertex, written like that. You know this formula?
Wouldn't be negative b over 2a.
Very good. What's that equal to here?
That would be 4 over 2, which is just 2.
So, if that, remember the best thing you can use to graph a parabola is the x and the y coordinate for starters. Well, we got the x coordinate. That basically tells me that there's a line of symmetry that goes right down there. And this parabola is going to be somewhere on that line. So if I know the y coordinate, I'll know where. How do I figure out the y coordinate?
You plug it back in.
Okay, what do you get?
You get 4 minus 8 plus 7.
Which is plus 3, I believe. Now we know exactly where the vertex is. It's right there. It's at 2, 3. Does this thing open up or does it open down?
Up.
Okay, so it's going to look something like this. But notice it could look like this, or it could be a skinny version. It might be a parabola that's been vertically stretched. So we don't know yet. We know where its vertex is, but that's it. And that's not really enough. In order to graph it properly, you have to have 3 points. Where am I going to get my other 2 points? Notice this thing does not cross the x-axis. What does that mean?
Wouldn't one be 7?
Yeah, let's get to that for after a second here. Let me just talk about what does it mean when you have a parabola that does not cross the x-axis?
It's, I don't
Doesn't
know.
have any real zeros.
Oh, okay.
There are no real numbers that satisfy this equation. There are imaginary numbers. In other words, if you were to solve this quadratic using the quadratic formula, you're going to see a square root of a negative number. In other words, necessarily you have complex solutions when you do not cross the x-axis. So that's one thing it means. Now, the 2 best points, usually finding the x-intercepts are what you would want to do next, because then you'd have 3 points, right? But there are no x-intercepts. So the next best point to find is that point and that point. Well, what's this point right here on the left?
7.
Good.
0.
0, 7.
0, 7, sorry, yeah.
Now, the point on the right, what's its y-coordinate?
That would be, the y-coordinate would be 14.
No? Look at that. Y-coordinate looks
to be
the
7.
same.
7.
Exactly. Now, what's
and then
the
it
next
would be 4, right?
Right. It's the same, because it's symmetrical, this distance is the same as this distance.
Right.
And that's 2. So this has to be 2, which makes that 4. So there's our 3 points. 2, 3 is the vertex, and those 2 points there. And that's always going to be the best way to get your 3 points when you're dealing with a parabola that does not cross the x-axis. It's really almost, yeah, absolutely the easiest way to get those other 2 points. All right.
All right. So determine whether the given numbers represent the lengths of sides of a right triangle.
Okay.
15, 12, and 9.
Don't have to draw a picture, but I will. If that's a right triangle, what has to be true?
9 squared plus 12 squared equals 15 squared.
Is that true?
That'd be 81 plus 144. Yeah, that is true.
Notice that if I divide each side by 3, I get a 3, 4, 5 right triangle. And you know about 3, 4, 5s, right?
Yeah.
When you get a 3, 4, 5, you don't have to do the Pythagorean theorem. So I actually could have eliminated that step by just dividing all 3 sides by 3. And then I'm looking at a 3, 4, 5 right triangle, and I know that's a right triangle. I don't have to prove it. In other words, any of your Pythagorean, like 5, 12, 13, which covers 50, 120, and 130. In other words, it's not just a 3, 4, 5, but multiples of 3, 4, 5s are also right triangles. But basically, the corollary is, if something is a right triangle, then the Pythagorean theorem has to hold, has to be true. Works both ways. If something is a right triangle, the Pythagorean theorem is true, and the corollary to that is, if the Pythagorean theorem is true, then it's a right triangle also. You cannot have a 3, 4, 5 triangle without it being a right triangle. Same thing with a 5, 12, 13. Okay, what else?
Okay, alright, multiply is indicated. If possible, simplify any square roots that appear in the product.
Okay.
Root 3, parentheses, root 21 minus root 3.
Like that?
Yep.
Okay.
So that would be root 63 minus root 9.
There's an easier way to do it. Always work with small numbers if you can. You don't want to have to deal with root 63.
Okay.
It's hard to deal with. It's a big number. So let's deal with root 21. Can you simplify it?
No.
Turns out, no. I'm sorry. I probably shouldn't have said something. I can't simplify it, but I can write it like this. Now, everything they teach you says don't do that if you can't pull a whole number out. But in this particular case, it actually is going to be helpful. Because now distribute.
Okay.
You get when you multiply this by this.
That'd be 9 root 21.
No, what's root 3 times root 3?
What? Root 3 times root 3 is 9.
No, it isn't.
Root 9, sorry.
Oh, okay, root 3 times, don't go up to 9. Just say root x times root x is x.
So just
You
3.
turn it into x squared and then take the square root of x squared. In other words, root 2 times root 2 is 2. Okay, so that becomes 3 root 7, correct?
Yeah.
Now, what's root 3 times root 3?
Root 3 times root 3 is 3.
There's your answer.
Okay.
Now, notice that it actually was helpful to break up root 21 into these two prime numbers. Because otherwise, we would have been faced with this. If we'd have done it the way, it's not a bad way to do it, but it's just harder to simplify that than it is to simplify 21. Turns out that that is square root of 9 times square root of 7, which becomes 3 root 7 minus 3. But still, it's all about keeping your numbers small, if possible, always. The way I did it, there was not a number bigger than 21.
Hello?
Can you hear me?
Yeah, okay, you might just cut out for a quick second.
The audio go out for a minute? Can you hear me, Blake?
Yeah, I can hear it.
Okay, cool. So there was an advantage in doing that, even though they tell you not to do that when you're simplifying root 21. In other words, root 21 is as simplified as it can get. It just happens to be kind of useful here, and it makes the arithmetic a little easier.
Okay.
So you can do it, it's just not considered a simplification. In other words, I'm never going to do, if they tell me to simplify that, I am not going to do it this way. because this way does not allow me to pull out any whole numbers. And
Right.
there's no other factors that would. So that is considered simplified. But sometimes if it's part of a harder, more complex problem, it does make sense to factor it into root 5 times root 2.
Okay.
Okay? What else?
All right. All right. A jogger goes 1.5 kilometers west and then turns south. If the jogger finishes 1.7 kilometers from the starting point, how far south did the jogger go?
All right. What you want to do on these is just draw pictures. Okay?
Okay.
So which way is west?
Or left, sorry, what?
Okay. No, that's correct. So the jogger goes 1.5 kilometers west, right?
Right.
Then he turns south. Which way is south?
It's down.
Okay. And we don't know how far he turned, but we know how far away he is from his original point, which is what?
1.7.
There happens to be a perfect Pythagorean triangle that is an 8, 15, 17.
Okay.
What's x?
What?
There is a perfect Pythagorean triangle, I even draw it in the same shape, whose sides are 15, 8, and 17.
Okay.
Rather than going through the math of the Pythagorean theorem, which is going to be complicated because you got decimals, use this. Does this triangle look similar to this triangle? It's a tenth of the other triangle. In other words, instead of 15, I got 1.5. Instead of 17, I got 1.7. So instead of 8, what am I going to have?
4?
1/10 of 8.
2 or what?
Hold on. Do you see how those two triangles are similar? Do you know what similarity means? They're the same exact shape, have exactly the same 3 angles, but they're not the same size. This triangle here, every side is 1/10 of the sides over here. See what I'm getting at?
Uh-huh.
So when you go to solve for this side, you don't have to do the math. You just have to recognize that this triangle is 1/10 the size of this other triangle that you know of, 8, 15, 17, assuming you know that. Not everybody knows that. But that's like the third one, I think. Yeah, I think that's 5, 12, 13 is the second one, and 8, 15, 17 is the third lowest one. So these low ones, it's good to know, because your tests are peppered with them. What they're looking to do is to give the person that recognizes that triangle a few seconds advantage over everybody else. Because everybody else is madly turning these numbers into their calculator, right?
Right.
But if you happen to know that there is an 8, 15, 17 triangle, then you don't need to use your calculator here. You can recognize immediately that the linear ratio is 10 to 1. So every side in this triangle has to be 1/10 every side in this triangle over here on the left. And it is. So that's how far he went south. It was 8/10 of a kilometer.
Okay.
You with me on this concept?
Yep.
Let's just go over your basic first three Pythagorean. They're called perfect Pythagoreans because they're the lowest three that have all integers. Tell me what that one is?
What do you mean?
No, I'm going to make it tougher. What's the hypotenuse on that one?
Um, uh,
Don't do it by math. Do it by recognizing what kind of triangle is this? Is it a 3, 4, 5?
yeah, so it'd be 50.
Uh-huh. See, you don't need to do any math. You just need to recognize that it's a 3, 4, 5. Okay.
Yep.
How about this one? What's the unknown side here? 12.
12. Okay.
5, 12, 13. Remember that one. Because between those two, that will cover half of the triangles they give you. I promise. Every now and then, when they want to make it just a little bit harder, they do that 8, 15, 17 one.
Okay.
Now, you don't have to remember any of these. You can always use the Pythagorean triangle or the Pythagorean theorem to solve for a third side when you're given two other sides. But it saves you quite a bit of time. It saves you 20 or 30 seconds. If you can save 20 or 30 seconds on a lot of problems, you're ahead of the class.
Okay.
All right, so what else you got? How long is your test? Is it an hour long? Normally?
Yeah, around there. Yeah, around there.
Is your final going to be about an hour?
Hour and a half.
Hour and a half? Okay. Well, it's
All
good
right.
we're doing an hour session then, because you kind of need to build up your endurance, if you know what I mean.
Right.
I don't know if you're a runner or not, but you don't practice for the marathon by running 100-yard dashes. You practice by running long distances. So if you're about to take a test that's going to be an hour and a half, requiring your focus for an hour and a half, you don't want to do nothing but half-hour sessions leading up to it. So
Right.
I'm glad to see this is an hour session. Just it gives you just a little bit more practice and staying focused for a full hour.
Yep.
Okay, so what else we got here?
Just a factor problem. 3x squared plus 8x minus 3.
Minus what?
3.
Okay. Just factor that expression.
Alright, so it'd be parentheses 3x and then x. Then just let's do negative, or,
The way to look at, the way to do this is it's plus minus
right.
or minus plus. In other words, it's opposite. But you have to write both of them because the coefficient of 3 is not the same as the coefficient of 1. That's when you write both of them. If these coefficients are the same, you don't have to write both of them. But if they're different, you always do. Tell me what to do next.
Just put a 3 and a 1.
And tell me what that gives you for an inside term.
Be 3x or negative 3x, and then
It's plus 3x plus a minus 3x. In other words, that one gives you plus 3x, this one gives you minus 3x. You add them together, you get 0. So that tells you a lot.
right.
I'm not going to accomplish anything by moving the 3 down and the 1 down. still going to get the same number, 0. Always. The only thing that's going to be different is the plus or minus sign in front of it. So, what's my next step? In other words, what's the next combination I should try?
1 and 3.
Yep. 1 on the left and 3 on the right. Now, what's the inside?
1x and then negative 9x.
Add them together.
Negative 8x.
Get the right number, but the wrong plus or minus sign. So what do I have to do?
I just do negative 1x plus positive 8x.
Just move those numbers down.
Right. So it'd be
to the other sign.
That'd be 1, negative 3.
Yeah, and then that's going to give you the same 8, but it'll give you the opposite sign. So it's a plus 8.
Right.
So that's the way you do those, by trial and error. You don't really usually have to try all 4 combinations. You just usually have to try 2 or at most 3. We had to try 3 here. But you never have to try all 4, because you can always eliminate one when you get one that doesn't work. Doesn't give you the correct number. Now, did they ask you to solve this? Was it
no, just type it.
Or they just asked you to factor it?
They just asked us to factor it.
Okay. What else you got?
That's all I have on the practice test.
Okay. Well, we only had 5 minutes left anyway, so that's fine. Let me just think for a second. If you had a weakness in any of those areas, if I could ask a last couple questions regarding that weakness. I can't really think of any weaknesses. What's this equal to?
That would be equal to just root 17.
Nope.
Or that would be, so it'd be 17 times 17, right?
No, it's equal to 17. Boy, this.
Yeah, why did I say root 17?
A lot of people. When I do this, it does not matter what x is. It can be any number you want. The answer is x.
Right.
I don't have to multiply 17 times 17 and then take the square root of it. That's a big, huge number. I'd have to get a calculator out to do that.
Right.
But I don't need to. As long as what's inside the radical is the same, then it's just that.
Mm-hmm.
Okay. I can't think of anything else to ask. I think you're in pretty good shape going into this quiz. Don't you?
Yeah, I think I'm good.
Good. Blake, have a good one. Good luck on your quiz, and I'll talk to you next time, where I imagine we'll be preparing for the final. Probably doing very similar stuff as this, but probably covering older stuff that you've done also, I imagine.
Yep.
Talk to you then.
All right, thank you. Bye.